Okay. Yeah, my video is off a little bit there. Okay, so we've talked about increasing, decreasing, or constant before, but now we're specific with a linear function. So an increasing linear function's like this. It's increasing. A decreasing linear function looks like that, only it's a straight line that I can't draw. And then a constant function looks like a horizontal line. That would be a constant linear function. Okay, so that you know, if it's increasing, the slope is greater than 0. If it's decreasing, the slope is less than 0. Oops, that's a 0. And if it's constant, the slope actually equals 0. Okay. So we have a little example here. Some recent studies suggest that a teenager sends an average of 60 texts per day. For each of the following scenarios, find the linear function that describes the relationship between the input value and the output value. Then determine if the graph of the function is increasing, decreasing, or constant. Okay, so part A, sorry to move it on you. Part A, the total number of texts a teen sends is considered a function of time in days. I'm going to use D for days, and I'm going to use my texts as T of D, which I don't know if that's the best notation, but that's what I'm going to use. So the input is the number of days, D, and the output is the total number of texts sent. So if they're sending 60 texts a day, then, no days, no text. But 1 day, 60 texts. 2 days, 120. 3 days, 180. So what are we doing? We're saying T of D is equal to 60 times D. That would tell you how many texts. You input the days, so if it's 20 days, I can tell you how many texts that there would be. Okay. And then I have to say if it's increasing. Well, every day that goes by, the teen is going to be sending more text, so it's going to be increasing. You can't take the text back. All right, so that would be an increasing function. All right, B. A teen has a limit of 500 texts per month in his or her data plan. The input is the number of days, so D again, and the output is the total number of texts remaining for the month. So I'll use R for remaining, R of D. Okay, so if you're trying to figure out how many are remaining, well, you're starting out with 500, right? Like you can have day 0, you have 500 texts that you can send. But then one day goes and you've sent 60 texts, right? And then another day, another 60. So it's going to be times how many days have gone by. That's going to decrease by your 500 by 60 every day that goes by. So you could write it this way. Another way to write it would be R of D equals negative 60D plus 500. So again, you could think about what the graph looks like. You're starting at 500 and then it's going to keep going down, right? So this is going to be a decreasing function. The slope here is negative, and the slope up here was positive, right? Okay. All right, let's do one more. A teen has an unlimited number of texts in his or her data plan for a cost of $50 per month. The input is the number of days, D for days, and the output is the total cost of texting each month. Well, your cost, depending on the days, doesn't really matter, right? But it's going to be $50 a month. So your cost isn't dependent on how many days go by, really, or how many texts the teen sends. It's just $50 a month. And this would be considered a constant function. If you graphed it, it'd make a horizontal line. Okay.